Alright guys, we're here for the notes on lesson 2.5. This is where things get fairly challenging for a lot of people, okay? So 2.1, the one-step equations for most people were easy. 2.2, the two-step equations, and 2.3, where you're writing equations, were really simple for almost everybody. 2.4, the last lesson, got a little more challenging with the variables on each side. But again, most people did really well with that. However, when we get here to 2.5, there are a lot of things going on, and it can get confusing for a lot of you, okay? So just remember that it really comes down to two things that we're going to be adding at the start of our equations. And now that we're in 2.5, this can happen at any point in time. And with these multi-step equations, we can see parentheses. And with parentheses, we're going to do something which is called the distributive property, which means we're multiplying out a number that's in front of a set of parentheses to everything inside, to each term. And also here in 2.5, we're adding in like terms. And like terms means that you have the same variable. Okay, so like 2x plus 3x would come together to make 5x. Or just a simple number like 3 minus 4 would come together to make -1. All right, so like terms, again, is what most people really struggle with. Or if you're struggling with the parentheses, it's a simple fix where a lot of people just only multiply by the first term and forget to multiply by the second term. So most people don't struggle with that, but some do, and it's a quick and easy fix when it's dealing with the distributive property. Okay? So anyways, here we go for the notes on lesson 2.5, which is solving multi-step equations. All right? So, for example 1, again, I'm not a huge fan of how they write these out, and so I can talk you through this. I'm going to bring this over to the side. I did mention the distributive property. You guys should have worked with that last year and in years past, just a little bit, but we're going to do a lot with it here in 2.5. Okay, so distribution property means we're going to take what's in front of the parenthesis and we're going to multiply by everything inside of the set of parentheses. Okay, so in this case we have two terms inside of our parentheses. We have a 4a and then we have a subtract 5, or the way I like to think of that is like a -5. Okay, so it's 2 times 4a, which is 8a. And then we have a 2 times -5, which makes -10. All right? And again, you could write that as 8a minus 10, or you could write that as 8a plus -10. It's the same thing, which is equal to 30. Now, like I said, technically, this is now just like the equations that we solved in 2.2. This is now just a two-step equation. So after we get rid of that parenthesis, okay, in this particular problem, there is no combining like terms. And what we do to combine like terms is we cover up and look at each side of the equation. So if we're covering up the right side and ignoring the 30, we're looking only at the 8a minus 10. And those two are not like terms because the 8 has the variable of a and the 10 does not have a variable. So those are not like terms. Then we cover up the left side and look only at the 30. Well, the 30 is already by itself, so there's no way that it has like terms on the right side of the equation either. So in this particular case, we get rid of the parentheses, and then it becomes just like equations that we solved way back in 2.2. So we draw in our line to help us remember the left side and the right side. The left side is more important because we have the a on that side. So I either could get rid of the multiply by 8 or the subtract 10, and because we're doing reverse order of operations, we want to get rid of the subtract 10 by adding 10 to each side. So our 8a drops down. If I have 30 and add 10, we now get 40. I divide each side by 8, and a is 5. Again, you could easily take that back and plug it into the equation to make sure that it works. And I will do that here for you since we have parentheses. Just to show you what this looks like, okay? So to check this, we go back to the original. So we keep the 2, we keep the parentheses, we keep the 4. We do not keep A, we replace A with 5. Remember, anytime you're replacing a variable or plugging in for a variable, you want to make sure that you're putting your answer, or what you think the answer is, in parentheses, okay? So now we work this out by doing the parentheses first. So inside of here, I have to do the multiplication first. So we keep the 2. 4 times 5 becomes 20. Then the subtract 5 comes down, which is equal to 30. I still can work the parentheses out, so 20 minus 5 becomes 15. All right, now I only have one answer inside of that parenthesis, and if I have a number directly in front of a set of parentheses, remember there's a hidden multiplication sign there. So 2 times 15 becomes 30, and because the left side and the right side are equal to each other, we know that we're correct. Okay? All right, here we go. Example number 2. Example number 2 is a little bit different looking, okay? This is called a bar model over here, and we're going to use that to help us out, all right? So example 2 says that we're talking about books. Roland has 3 paperback books and 4 hardcover books. Each hardcover book is worth $11 more than each paperback book. If the value of all of his books is $79, what is the cost of one paperback book? So over here to the side, this is called a bar model, as I mentioned, okay? We have our paperback books that are over here. And so they chose to use the letter P. Since this is a real-world problem, using the letter P makes more sense with this equation. All right, and if I could rewrite paperback plus paperback plus paperback, P plus P plus P, this really stands for 3P. All right, and then on the bottom, we know that I also have these hardcover books. And it says we bought 4 hardcover books, and in relation to the paperback, we know, based on the information that they gave us, that each hardcover book is the cost of the paperback book plus $11. Okay? So that's where this P plus 11 comes from. And another way to write this, or a better way to write P plus 11 plus P plus 11 plus P plus 11 plus P plus 11 is to say, I'm going to take that and multiply by 4. And so that's where our parentheses come into play. All right? So we bought the 3 paperback books, plus we bought the 4 hardcover books, and each one of those was P plus 11, and we spent in total $79. So all of that comes down here to this equation that they already have written out. Okay? So, just like we did in example 1, the very first step, anytime that we're working with these multi-step equations, is we want to get rid of the parentheses first, okay? So to get rid of those parentheses, we need to take the 4, and we need to multiply by each of the terms inside of the parentheses. So this 3P out in front has nothing to do with it, so it just drops down. Now, I am going to remind you that this sign out in front is important, because the plus sign tells us that we're multiplying by a positive 4. If there was a subtraction sign there, we would want to multiply that entire set of parentheses by a negative number. Okay? So, positive 4 times 1p, so that gives us 4p. And then positive 4 times positive 11 makes positive 44. And on the right side, the equal 79 just drops down. Now, like I said, this is, getting rid of the parentheses. And after we get rid of the parentheses, the most important thing we look for is to make sure that if we have like terms, and I say if because it doesn't always happen. So if we have like terms, they need to go together first. That will really help us get these equations shortened up so it doesn't seem so long and difficult, okay? So I'm looking only at the left side of my equation. So I have a 3p plus 4p plus 44. And these two terms right here are important because they both have the same exact variable of p. So they can go together because they are like terms and they're on the same side of the equation. So the 3p plus 4p comes together to make 7p. The 44 does not have another like term on the left side of the equation, so it just needs to drop down. And now on the right side of the 79, again, doesn't have any like terms on the right side of the equation, so it drops down. I now am ready to draw my line because I have a two-step equation, and I'm ready to solve that. So the 44 needs to move by using subtraction. So the 7p is equal to 35. I want to divide each side by 7, which gives us a final answer of p equals 5. I'm going to go back up and read that last sentence and see what it's asking us to find. It says, what is the cost of one paperback book? So I now know that because this is a word problem, it's going to cost $5 for each paperback book. Okay? All right. Here we go. Take a look at example number 3. Okay? So, example number 3, again, that's something that I didn't mention at the start of these notes. Not only are we adding the like terms in, are we adding the distributive property in, but sometimes we're going to have these special cases where I don't come up with an accurate answer of x equals 5 or p equals 5. Okay? We're going to have some of these that no matter what you do, they're not going to work out at all. And so your solution is to have no solution at all. And then on the flip side of that is sometimes no matter what number I plug into the equation, the left side and the right side of the equation will always be equal to each other because they're identical to each other, also called the identity property, where your left side of the equation and the right side are identical to each other. And so we talk about that by having infinitely many solutions, or a lot of times we call that all real numbers and abbreviate that with ARN. Okay? So let's take a look over here. I want to kind of explain this a little bit more of how we came up with that answer of 4 equals 0. So if our original equation was 3x plus 4 equals 3x, we kind of go through those steps that we talked about at the start here for 2-5. First thing, do we have parentheses? No, we don't have any on the left side or the right side. Second thing we do is cover up one side of the equation and look for like terms. So I'm looking at the 3x plus 4. Those are not like terms because one has a variable and the other one doesn't. And on the right side of the equation, I only have a 3x, so it can't go together with anything. So I'm ready to solve my equation, so I draw in that line. And when I draw in that line, I'm always looking for where the variables are at. I notice that there is a variable on the left side and on the right side, and I don't want that. I need them to get together, okay? So, 2-4, we talked about moving the smaller variable anytime that we could. So I noticed that there's a 3x, and on the right side, there's also a 3x. This is the first time that we've ever seen the same exact variable on the left side of the equation and on the right side of the equation. And that is why we're getting one of these special answers of either no solution or all real numbers. Okay? So if we choose to subtract 3x, to move it, it goes away on the left side, so the 4 drops down, and it goes away on the right side. And as we talked about again in 2.4, the last notes, if there's something that's going to go away completely and not have something to bring down on the side of the equation, we have to bring down the 0 to hold that place value that says there's something here, it just happens to be a 0. Okay, so now we ask ourselves a question. Is this a true statement or is this a false statement? So is 4 equal to 0 is a false statement. And a false statement tells us that our answer is no solution. Okay? So we don't just say false, but because of the false statement, we know that it's no solution. Now, here in the middle, the one solution, that's exactly what we've dealt with in 2.1, 2.2, 2.3, and 2.4. You have an equation, and you end up with a variable on one side of the equation, which is equal to a number on the other side of the equation. Okay? So a one solution, that's exactly what we've dealt with in 2.1 all the way through 2.4. So that's nothing new. But on the other side, on the infinitely many solutions or all real numbers, this is what's happening when we end up with one of those. So first off, some of you can just look at this and tell the left side is identical to the right side. And so that's why it's called the identity property sometimes, all right? And because it's identical to each other, all right? And when that happens, we're going to have, no matter what we plug in, it's always going to work. The left side will be identical to the right side, all right? But again, just to prove it, we don't have parentheses, we don't have like terms, so I'm ready to move the smaller of the two variables. And what do you notice? Again, we have the 4x on the left side and the 4x on the right side. And because of that, we know we're going to end up with one of those strange answers. We're going to end up with 2, which is equal to 2. And this time, instead of being a false statement, that is a true statement. And with a true statement, that leads us to the answer of all real numbers. Okay? All right, so there's a lot of things going on here in 2.5. However, I think if you just think of it as in steps. Step number 1, get rid of your parentheses by using multiplication. Step number 2, if it happens, okay, is to combine your like terms. And then the other thing that's important is just to remember that if you have the same variables on the left side of the equation and the right side of the equation, you will have the possibility of getting a no solution for your answer or an infinite number of solutions, which is called all real numbers. Okay? All right, flip your paper over, take a look at the back. Again, we could check our solutions, but I'm going to leave that out for right now because I know time on this video. All right? So, first step, get rid of the parentheses. 2 times 3b is 6b. 2 times -1 is -2, which is equal to 40. Left side of the equation, the 6b subtract 2 cannot go together. They're not like terms. 40 on the right side cannot go together. It's not a like term. I draw my line, add 2 on each side. 6b equals 42. Divide each side by 6. b equals 7. Again, you could plug it back in and check it just to make sure. Okay? Number 2. Can't do anything with the 49, so it drops down. On the right side, though, we do have our parentheses, so we want to take -7 and multiply by t, and then take -7 and multiply by 1, which gives us -7. We then don't have like terms on the left side, don't have like terms on the right side, so we draw our line. I notice that the right side is more important because our variable of t is there, so I want to get rid of the subtract 7 by using addition. That gives us 49 and 7 would be 56. And then the -7t drops down. We want to get rid of -7 by dividing by -7 on each side, which gives us a final answer of -8. On the right side, we want to get rid of the parentheses again before we start to solve. So 5 times 1 is 5. 5 times a -1n is -5n, which is equal to 75. Again, don't have any like terms. The 5 and 5n cannot go together, and the 75 doesn't have anything on its side either. So we're ready to solve again. So I want to get rid of the 5 out front. And in front of that 5 is nothing, so we're subtracting 5. So this subtract 5n drops down and becomes negative 5n. If I have 75 and subtract 5, we get 70. And now I want to divide each side by negative 5. Okay? So, when we divide by negative 5, we end up with a total of negative 14. Okay, number 4. This time I have parentheses on the left and on the right. So we have to be a little bit careful. If I ever have more than one set of parentheses, we work from the left side to the right side out first. Okay? So 4 times x is 4x. 4 times negative 2 is negative 8. And then on the right side, we go ahead and distribute those as well. So 3 times x is 3x. And 3 times negative 3 is negative 9. Okay, covering up the right side of the equation, only looking at the 4x minus 8. Those two are not like terms. They cannot go together. Looking at the right side of the equation, we have 3x minus 9. Again, they are not like terms. One has a variable, one does not. So I'm now ready to draw my line. And I notice that I have a variable on the left and on the right side of the equation. So I want to move the smaller of the two. I have a 4x or a 3x. So 3x is smaller. In front of the 3x is no sign, so that means I want to subtract so that it becomes 0. So if I have 4 and subtract 3 from it, we get 1x. The subtract 8 comes down, and the subtract 9 comes down and becomes negative 9. Okay? Left side is now more important because that's where the variable is. So I want to get rid of the subtract 8 by using addition. The 1x drops down, and I have negative 8 plus 8, negative 9 plus 8, which gives me a final answer of negative 1. Number 5. Again, more than one set of parentheses, so we work the one on the left side first. So we get negative 5p, and then negative 5 times 2 is negative 10. I'm going to write that as subtract 10. Our next set of parentheses is 2 times 2p, which becomes 4p. We have 2 times negative 15, which is subtract 30. And then I do not multiply that last thing because it's outside of the parentheses. So the plus 1p just drops down without being multiplied. All right, left side of the equation, I have negative 5p, subtract 10. One has a variable, one doesn't, so they are not like terms. They cannot go together. However, on the right side, I have a 4p and I have a 1p. So what we do is we put them together by whatever sign is in front of the second like term. So in front of the 1p, I have a plus sign. So the 4p plus 1p become 5p. And the subtract 30 drops down. And on the right side, the left side, like we said, we could not do anything with it, so we brought it down. All right? Now, because I have my like terms together, I had the parentheses taken care of, I'm now ready to solve the equation by drawing the line in. I notice I have a negative 5p on the left and a positive 5p on the right. So they are not the same, okay? So what we need to do is we need to move the smaller of the two. So that negative 5p is what we want to move by adding 5p to each side. The subtract 10 comes down and becomes negative 10. 5p plus 5p becomes 10p, and the subtract 30 falls in behind it. Now the right side of the equation is more important because that's where the variable's at. I need to get rid of either the multiply by 10 or the subtract 30. And we want to get rid of the subtraction first by adding 30. Negative 10 plus 30 becomes 20. The 10p drops down. To get rid of the 10, we have multiplication between there. So to get rid of that, we need to divide each side by 10. 20 divided by 10 makes 2, which is equal to p. And number 6. Okay, left side of the equation, no parentheses. So we're going to drop it down. 8z minus 22. Right side does have parentheses, so we distribute. 3 times 3, 9z. 3 times positive 11 is positive 33. Again, I have a like, or not a like term, but I have a letter outside of the parentheses, so we're not multiplying that by 3. We are bringing that down as is. Okay, so that subtract z comes down and becomes subtract 1z. On the left side, 8z minus 22 cannot go together. Right side, I have a 9z and a subtract 1z. So if they go together, it makes 8z on the right side. And on the left side, I have 8z minus 22. Draw my line. And again, I notice I have a variable on the left and a variable on the right. So the smaller of the two is what we always want to move. I have 8z on the left and 8z on the right. So immediately you should know that because I have the exact same variable on the left and on the right, I'm going to end up with either all real numbers or no solution. Okay? So when we subtract the 8z, it goes away on the left side and drops negative 22. On the right side, it goes away and drops a positive 33. So the question we always ask ourselves, is this a true statement or is this a false statement? So negative 22 is not the same thing as 33. So that makes a false statement, which tells us our answer is no solution. All right, and your favorite word problem. Okay, so just because we go on to something a little more difficult doesn't mean that we drop, excuse me, the word problems out. So number 7 says we're at the fair and Hunter bought 3 snacks and 10 ride tickets. Each ride ticket cost $1.50 less than a snack. If he spent a total of $24, what was the cost of each snack? Okay, so he bought 3 snacks and 10 ride tickets. And we know that a ride ticket was $1.50 less than a snack. So this one's a little bit strange, okay? So we know that we bought 3 snacks, so that's a cursive S there that I'm using. Plus we bought 10 ride tickets. But I can't use the same variable right now, and I can't use a separate variable because then we couldn't solve it. So what we need to do is we need to look at this piece right here. It talks about each ride ticket is $1.50 less than a snack. So if we know what the snack costs, we're going to subtract $1.50 from it. And in total, Hunter spent $24. Okay? So now we have the equation set up. We need to get rid of the parentheses first. So the 3s just drops down. Over here, I'm going to take this positive 10 and multiply each of these terms. So positive 10 times s is plus 10s. Positive 10 times negative 1.50 is negative 15. And anytime we get rid of the parentheses, we want to look for our like terms. So on the left side of the equation, I have a 3s and a 10s that go together to give me 13s. The subtract 15 comes down, which is equal to 24. All right, draw my line because I'm ready to start solving it. Notice that I only have a variable on the left side, so I need to get rid of either the 13 or the 15. And I want to get rid of the 15 because it's subtraction. So we're going to add 15 on each side. So that gives me 13s, which is equal to 39. Divide each side by 13. And s is 3. and then I'm going to go back up to the problem and reread it and make sure that we answered the correct question. So the last sentence says, if he spent a total of $24, what was the cost of each snack? So this is $3 per snack. All right, and that will finish up our notes here on lesson 2.5.